Hey guys, so welcome to this session. Here I am going to discuss a question from the back exercise, question 5.13 from page 5.80. The question says that df is equal to y0 into x minus x squared dx. This is my PDF where x lies between 0 and 1 and y0 is a constant. We need to find the arithmetic mean, the geometric mean, the harmonic mean, the mean, median and mode. In the second part, we need to find the rth moment about mean. The rth moment about mean will be which is equal to ex minus mu bar r, right? And beta 1 and beta 2. Also, we need to show that the distribution is symmetrical. And when is the distribution symmetrical? A distribution is symmetrical when beta 1 is equal to 0. In the third part, we need to find the mean deviation about mean. So this is a very big question. A lot of parts. I would obviously need to look up the formulas from the book. So let's just first find the mean, the arithmetic mean. The arithmetic mean will be x fx dx, and the limits, my limits are 0 to 1. So my limits are 0 to 1. X fx dx 0 to 1, and y0 is a constant. So I guess we need to find y0 first. Let me just check if we need to find y0 also, or if it's of any use. Alright, so in this question, we have to find y0 also. Yes, we need to find y0 also. So let's just first find y0, the value of y0. Let me check if the recording is still going on. Yes. Right, so let's just first find y0. Right, let me just remove all of this. Right, so finding y0, my PDF is y0 into x minus x square dx 0 to 1. This should be equal to 1. So I can take out y0 because it's a constant term. So this becomes 0 to 1 x minus x square dx, which is equal to y0 into x square by 2 minus x cube by 3, 0 to 1, right? And this becomes y0 into 1 by 2 minus 1 by 3 minus 0 is equals to 1, and this becomes y0 1 upon 6. This becomes 1, which implies y0 is equal to 6, right? So our PDF will be, moving to the next slide, our PDF will be df is equal to, it's written df terms, so this becomes 6 x minus x square dx, where x lies between 0 and 1, right? So now moving forward, yes, so moving forward, x minus x square, we need to find the arithmetic mean. Arithmetic mean, x of x dx 0 to 1, 6 x into x minus x square dx 0 to 1. This becomes arithmetic mean is equal to 6 into, so x square becomes integrating x square, we get x cube by 3, and x cube. So integrating x cube, we get x4 upon 4 and the limits are 0 to 1. This gives me 1 by 3 minus 1 by 4, which gives me the arithmetic mean to be equal to 12. 4 minus 3 into 6, which is 1 upon 12 into 6, which is 1 by 2. So my arithmetic mean is 1 by 2, right? Now let's find the median. I'll be finding the geometric mean and the harmonic mean later. So let's just find the median. Median is, for median we need to find a number m such that if the for example the limits are from a to b. For example, let's just say that x lies between a and b. So m will be any number, such that when I integrate it from the lower limit to m, the value that I get of fx dx should be equal to half. The probability of integrating this PDF from the lower limit to any number m should give me half, and if this happens, we say that m is the median, right? So now if you remember the first question that I discussed, first or second question that I discussed, in that question we needed to find the median, but the domains were changing. Here our domain is same, so x lies between 0 and 1 only. So my m lies between 0 and 1, so I can take the limit to be 0 to m. So for median, this becomes wait. So for median 0 to m fx dx, so 6 comes out because it's a constant term. X minus x square dx should be equal to half, so this becomes x square by 2 minus x cube by 3, 0 to m. This becomes m square minus m cube by 2 by 3, which gives me the value half. This ultimately becomes 3m square minus 2m cube by 6, and this should be equal to half. 6 and 6 gets cancelled. This was 6, so 6 and 6 gets cancelled. Now what I'm left with is 3m square minus 2m cube, 3m square minus 2m cube is equal to half, where m is my median. So I need to solve this equation. 6 taking to the LHS, 4m cube is equal to 1. This gives me 4m cube minus 6m square plus 1 is equal to 0, taking all of that to the RHS, all of the terms on the LHS to the RHS. 4m cube minus 6m square plus 1 is equal to 0. So I need to solve this equation now. What can I put? Can I put m is equal to half? See, now while applying trial and error to solve this cubic equation, I'll try to put in values that lie between 0 and 1. 0 and 1. Why? Because my median would definitely lie between these values. If my median does not lie between these values, then my answer is wrong, right? So let m is equal to half. So this gives me 4 into 1 by 2. The cube of 1 by 2 becomes 1 by 8. This is 4 minus 6 to 1 by 4. The square of 1 by 2, 1 by 4 plus 1 is equal to 0. I need to check this if it's equal to 0. So removing this plus 1 is equal to, so this becomes 1 by 2. 2 3s are 6, 2 2s are 4, so this becomes half minus 3 by 2 plus 1, and 1 plus half is 3 by 2, so this becomes 0. Yes, so m is equal to half is our one of our roots, so m minus half is one of our values. I can stop at m is equal to half, and there is no need to find the other values, but let's just find m minus half. So if I just apply long division here, 4m cube minus 6m square plus 1, multiplying this by 4m square, this gives me 4m cube plus minus, this gets cancelled, so 4m square into minus half, this gives me minus 2m square minus 2m square plus, this becomes plus, so this gives me minus 4m square plus 1, and multiplying this by 4m minus 4m, right, made some error, 4m square 4m cube minus 2m 4m square minus half, so 2 and 2 goes away, minus 2m square, yes, minus 2m square, this gives me minus 2m square, and this becomes plus, so this is minus 4m square plus 1, and multiplying this by 4 minus 4m, this gives me minus 4m square, and this gives me plus 2m and minus, so this becomes this gets cancelled, plus this gets cancelled, minus 4m square, so this goes away. I'm left with 2m minus 2m plus 1. So if I just multiply this by 2 minus 2, this gives me minus 2m, and this gives me plus 1, so this becomes minus and this becomes plus, cancelling all of that, my remainder is 0. Hence this is my equation, my quadratic equation. This will give me 2 more roots, so 4m minus half into 4m square minus 4m minus 2, 4m square minus 4m minus 2, and this is equal to 4m cube minus 6m square plus 1, right? So solving this equation, 4m 4 into 2 8, 8 4 into 2 8. Can I find the b square minus 4ac value of this? So b square minus 4ac, this gives me 16 minus 4 into a, which is 4, to minus 2 minus 4a into 4 minus 2, this gives me 16 and 2 32, so adding this 32, this is 8 and this is 4, 48, root 48, and my roots are root 48, this will be root 48, so m is from this equation, so this gives me m is equal to half, and this equation will give me 2 more roots, so m is minus b, so this is plus 4 plus minus root 48 upon 2a, a is 4, so this is plus minus root 48 by 8, right? So this is 8, so root 48, see, root 49 is 7, is 7, so root 36 is equal to 6, therefore root 48 should lie somewhere between 6 and 7, right? Root 49 is equal to 7, root 36 is equal to 6, so root 48 should lie somewhere between 6 and 7, right? So so clearly if I take the root as 4 plus root 48 by 8, so this gives me some value greater than 8 in the numerator, right? Clearly, if I take 6, I'll be getting 10. If I take 7, I'll be getting 11. So this value clearly lies between 10 and 11, and dividing this by 8. So this gives me a value greater than 1. So I'll be rejecting this. Why? Because my median should lie between 0 and 1, right? So rejecting this because the value is greater than 1. So I'm rejecting this value. Now for the second value, this is 4 minus root 48 upon 8. Again, see, root 48 lies between 6 and 7. So if I take the value as 6, this will give me 4 minus 6 minus 2. And if I take the value as 7, 4 minus 7 gives me minus 3. So my value will be somewhere in between 3 and minus 2 upon 8, which is clearly less than 0. Therefore we will reject this again, because this value does not lie between 0 and 1, and therefore this implies that this cannot be the median, right? So we are rejecting both of these values. So our median will thus be m is equal to half. This is our median, right? If you have any doubts, the formula that I used here is a basic formula to calculate the value of the roots of quadratic equation, which is minus b plus minus root b square minus 4ac upon 2a. This is the formula that I used here to find the roots of the quadratic equation, right? So you can just remember this if you have forgotten, right? So this is our median. Median is half. Our mean was also half. What if our mode is also half? Then can we say that our distribution is symmetrical? In normal distribution, the mean, the median and the mode, both of these three are equal, right? So we say, and we also know that normal distribution is a symmetrical distribution. But let's just find the value of beta 1, which being equal to 0 will tell us that the distribution is symmetrical, right? So moving forward, let's find the mode. So how do we find the mode? For finding the mode is the value that is occurring the maximum number of times. So fx, this was my PDF, 6 into x minus x square, right? So I need to find the value. We need to find the maximum of this value, right? So I need to find the x which maximizes this. So we need to find max of 6x minus x square, right? So how do we find this? This is a single variable optimization problem, very easy. So we just find the first derivative for the stationary point. This gives us 6 minus 12x, right? So 6, the derivative of x is 1. 6 minus 2x is 6 minus 12x, putting this as 0. So this gives me 6 is equal to 12x, which implies that x is equal to half. Again, now we need to check if this function is a concave function or a convex function. Mainly we are finding the maximum value, so we need to check if this function is a concave function. If this function is a concave function, then we can imply that our stationary point is a global max. We need to find the global max here. So inserting some new slides. It's a very basic optimization problem. So I need to review for my pens. Yes, so this is my pen. So this gives me x is equal to half. So the first derivative was 6 minus 12x, and the second derivative is minus 12 less than 0. This tells us that fx is a concave function, and when fx or any function is a concave function, then we can say that the interior stationary point, let me write this again, then you can say that the interior, because actually this is not defined over a domain, this maximization problem that I was solving was not defined over a domain, so I don't need to write this interior point, but so I don't need to write this, I can skip this. So you can say that the stationary point, or wait, let me just tweak this a bit. We were already given that x lies between 0 and 1, so now if I'm writing this goes, I can write this, that the interior stationary point, now this value, this gave me x is equal to half, right? So when fx is a concave function, then we can say that the interior stationary point is a global max. That fx is a global max. So our mode is x is equal to half. There might be some sound coming from my background, very sorry for that. So my mode is x is equal to half, right? I just wrote this for your explanation. So when fx is a concave function, then we can say that the interior stationary point is a global max. So mode x is equal to half. Now what all I need to find? So we have found the mean, median and mode. So all three of them are equal. Let me just write this. So the mean, the median and the mode, all three of them are equal to half. Indicates a symmetrical distribution. This is the property of symmetrical distribution, but let me just find what all I need to find except for this. So the geometric mean and the harmonic mean. Let's just find the geometric mean and the harmonic mean. But for finding the geometric mean and the harmonic mean, I need to look up the formula. I don't remember the formula. So let me just insert some more slides. So right, so the geometric mean, the formula for the geometric mean, I'm just going to look it up from my book. The geometric mean is log g is equal to a to b log x fx dx. This is the formula for the geometric mean, right? Log g is equal to a to b log x fx dx, right? So now to find the geometric mean, six I'm taking out. Wait, why did I write a to b? This is 0 and this is 1. This is the formula. So 0 to 1 log x fx I'm taking out 6 and this becomes x minus x square dx. I'll be applying IL8 here, right? IL8 is a simple rule. It's not a standard rule, but we use it to integrate functions. So I'll take this as the first function. Log, inverse, log, algebraic, trigonometric, exponential. So algebraic comes second. So this is my first function. This is my second function. So my formula is the integral I is equal to the first function. My integral is equal to the formula for IL8, applying IL8 is the first function, the integral of the second function minus the derivative of the first function, I dash, and integrating the second function. Right, so this is the formula. Now let me just draw a line. Right, so log x was my first function, log x is my first function, and x minus x square is my second function. So this becomes my log x is equal to my log g. Log g is equal to 6 log x, the integral of this x square upon 2 minus x cube by 3 minus the derivative of this becomes 1 upon x into the integral of this becomes x square by 2 minus x cube by 3. Right, and I'll just put the limits at the end in this function. Right, so this gives me log g is equal to 6 log x. This is also right 0 to 1. Actually this will also have 0 to 1, the limits 0 to 1, the whole function. So this becomes log x into x square by 2 minus x cube by 3, and this becomes, so taking out x common, this gives me x square and x square goes away, so x upon 2, so x upon 2 becomes x upon 2 becomes x square upon 4, because I already had a 2 in my denominator, and the minus sign, and minus minus becomes plus. So this, taking this out, this I'm left with x square in the numerator when I cancel this and this, so x square in the numerator and 3 in the denominator. This gives me x cube by 9. So yeah, so x to the power 2, so upon 3, so this integrating this gives me x cube upon 3, so 3 into 3 9, and this becomes x cube. Right, so now applying the limit 0 to 1, just writing this. So log g gives me 6 into, now log 1 is 0, so this becomes 0, minus 1 upon 4, wait, let me just write this as, let me just write this as negative, because I did a mistake here. I accounted for the negative sign earlier only, so this is minus, so this becomes minus minus plus later on. This is minus only, this is minus only after integrating, and this minus minus becomes plus, so minus minus becomes plus, so this is minus only, so minus 1 by 4, and minus minus plus, so this becomes 1 by 9. Right. I guess I did a mistake here. I'm not sure. my G cannot come out to be negative. Right, so this becomes minus 9 plus 4 minus 5. How can is my geometric mean negative? I need to check. 6 into 36, 5 minus 5. This is 4 and this is 9, so this becomes minus 5. This gives me minus 5 upon 6. So this is minus 5. Going to the next page. I need to check my answer. I did some mistake, I guess. So this gives me 6 into minus 5 upon 36, which is 6 and 6 goes. So this 6 and 36 goes. I am left with minus 5 upon 6. So log G is equal to minus 5 upon 6. Let me just check. If I made some error, I'm just checking my answer. Only the answer is given here. 5.80. Yes, so we are correct here. So G becomes, so this is log and my base is E, so this becomes G is equal to e to the power minus 5 upon 6, right? So this is my geometric mean. I needed to just convert this in. So this is correct. So this is my geometric mean. Now for harmonic mean, I need to look up the formula. Yes, so the harmonic mean is the formula for the harmonic mean is 1 upon h equals a to b 1 upon x fx dx. 1 upon x fx dx. This is 1 upon h equals to, my limits are 0 to 1, 1 upon x, 6 comes out, x minus x square dx. So taking x out common, this gives me 1 upon h is equal to 6 into 0 to 1. So I'm left with, x comes out, so I'm left with 1 minus x dx, which is 6 into x minus x square by 2, 0 to 1. This gives me the harmonic mean as 6 into 1 minus 1 by 2, which is equal to, and subtracted by 0. So this gives me 6 into half, which is 3. Harmonic mean is the inverse of 3, that is 1 by 3. H is 1 by 3, the harmonic mean. Right. Now this should be correct. I'll be checking it at the end. So what do I need to find after that? After this. So this is I need to find the rth moment. So I've found the arithmetic mean, geometric mean, the harmonic mean, the mean, median and mode, the rth moment about mean, and beta 1 and beta 2, and show distribution is symmetrical. And for showing distribution is symmetrical, my value of beta 1 will come out to be equal to 0. So I need to find the rth moment about mean. Rth moment about mean. So my rth moment about mean. So if we need to find the rth moment about the origin, I would have put 1 dash, and this would have been equal to x minus 0 to the power r, and this would be equal to this part. We don't need to find this, but I'm leaving this is correct, so I'm leaving this here only. We need to find this, which is e x minus mu bar r. Now we know that the value of mu is mu or the first moment with respect to the origin, which is Ex, and we found this, the arithmetic mean, and this was equal to half, I think. Let me this is half only. This is half only, so this is half only, right? This is half only. So I need to find which is so this is 0 to 1, x minus half to the power r, 6 comes out, x minus x square dx. So how do I integrate this? Separating this gives me 6 into 0 to 1, 0 to 1, x minus half power r into x minus x square into x minus half to the power r, 0 to 1 dx, putting a bracket here. So this gives me right, so this becomes 0 to 1. Now this is x minus half power r into x dx minus 0 to 1 x square x minus half to the power r dx, putting another bracket. So let x minus half be equal to t, so dx is equal to dt. So when x goes to 1, t goes to half. When x goes to 0, t goes to minus half, right? When x goes to 1, t goes to half. When x goes to 0, t goes to minus half. So my limits are minus half to half, and I'm left with t to the power r, and x is t plus half. So if x minus half is equal to t, x minus half is equal to t, this implies that x is equal to t plus half. So I'm just writing this as t plus half dt. Again, if I do the same thing here, my value becomes minus half to half. Now my x is equal to t plus half, so this will become t plus half, the whole square of t plus half into t to the power r dt, right? Going to the next slide, this gives me 6 minus half to half t to the power r plus 1 plus half into t to the power half t to the power r dt. This becomes minus half to half t square plus 1 by 4 plus multiplying half into, so this becomes t multiplied by t to the power r dt, putting another bracket here. This gives me this becomes t r plus 1 plus 1, so r plus 2 upon r plus 2 plus half t to the power r plus 1 upon r plus 1. So this is 2, right? So putting in the limits, minus half to half, and this gives me t to the power r plus 2, and integrating this will give me t to the power r plus 3. right? So t to the power r plus 3 upon r plus 3, right? So and this is 1 by 4 t to the power r, so this gives me t to the power r plus 1 upon 4 into r plus 1. Now this becomes t to the power r plus 1, so this gives me t to the power r plus 2 upon r plus 2. Integrating this gives me, and my limits are minus half to half. And another bracket here. I need to put in another bracket here. There is another bracket here, right? I hope you are understanding this, you're getting this. So this gives me 6 into putting in half in the place of t, so half to the power r plus 2 upon r plus 2 into 1 upon r plus 2 minus half, this is half to the power r plus 1, and another half, this gives me half to the power r plus 2 again. So this becomes half to the power r plus 2, right? So half to the power r plus 2 into 1 upon r plus 1, and again now I need to substitute minus half also. This is a bit lengthy. This gives me C. So this is minus and r plus 2. Now we need to find if r is odd or even, or I can also leave it on the previous step. I can also leave it on the previous step. I don't need to put in the limits. We need to find the rth moment. So if I just clear this out using the expression above, using the expression, this expression that we just found, let me just check if the recording is still on. Yeah. So if I just put in the value, so if r is equal to 1, what is 1? If r is equal to 1, this becomes the first moment with respect to the mean, or with respect to the origin. So this is just the mean. This is just the mean. So if I just put in, this should be equal to half. If all that I did above is correct, then on putting r is equal to 1, in this will give me the first moment, and the first moment is the mean, and which we found out to be equal to half. So if this expression after substituting r is equal to 1 gives me half, then I can conclude that my rth moment, the expression for the rth moment that I just found, happens to be correct. See, I could have easily substituted half here, but substituting minus half would have been tricky, because I don't know if r is odd or even, right? So if r was odd, so odd, if I add 2 in any odd number, so if r is equal to 3, 3 plus 2 gives me 5, so, and 5 plus 2 would have given me 7. So yeah, so I would have gotten a odd number, right? So this should have given me a negative half. And if r was an even number, for example r is 4, then then the power would have become, r plus 2 becomes 6, so that would have given me a positive half after substituting minus half in the expression. So this would have made a difference. That's why I'm not putting in the limits and finding the answer, though there will be some terms that can get cancelled here, but I'm just showing you. After putting in r is equal to 1, let r is equal to 1 in this expression, this becomes mu1, and 6 into t to the power 3 plus upon 3 plus half into t to the power 2 upon 2, substituting minus half and half, minus t is t to the power 4 upon 4 minus t to the power 2 upon 4 into 2 plus t to the power 3 upon 3, right? T to the power 3 upon 3. Let me just go to the next slide. This is not clear enough. I'll be writing this again. So this was, so mu1 is 6. I'm just checking. This should come out to be equal to, this should come out to be half. So this was t cube upon 3 plus half and half becomes 4. So t square minus half to half minus t to the power 4 upon 4 minus t square, and 4 into 8, so minus t square and 8 plus, this was t to the power 4 minus t square by 8 plus t cube by 3 plus t cube by 3 plus t cube by 3, substituting minus half and half, putting in another bracket. This should give me a value equal to half, which is my mean on my first moment. Taking out, can I take out t cube common? Right, so t cube I can take out. So this gives me 12, and this becomes 7 upon 12 minus half to half, and this now, wait, I can't take out t cube common. I have t square. So I need to solve this. Substituting half and minus half in place of t, this gives me, this becomes 1 upon 8 into 24 plus 1 upon 4 into half square gives me 16, 1 upon 16, and 1 upon 4, 24, and because this was 1 upon 8 into 3, 24, and 16, and and 4, this was 4 and 4, 16, 1 upon 4, yes. And then substituting minus half here in this expression, I'm just substituting minus half. This gives me minus 1 upon 24, and the whole square of minus half gives me 1 by 4, so this becomes plus 1 by 16, 4 and 4. So now the next expression, let me draw another bracket here. Right, so right, so just substituting half and half, this gives me 2 to the power 4 is 16, so 16, 64, 1 upon 64, 1 upon 64 minus 1 upon 8 into 4 gives me 32 plus 8 into 3, 24, 1 upon 24. Now drawing another bracket here, minus, now substituting minus half here gives me again 1 upon 64, again 1 upon 32, but here the value will change and this will become minus half, so this becomes minus 1 upon 24. Right, so now I need to just solve this up. This gives me 1 upon 24 plus 1 upon 16 plus 1 upon 24 minus plus minus 1 upon 16, and this becomes 1 upon 64, 1 upon 64 minus 1 upon 32 plus 1 upon 24. Now this becomes minus 1 upon 64 minus plus 1 upon 32, 1 upon 32, and this becomes 1 upon 24 plus minus plus, right? So these are the two expressions. This goes away, this goes away, this goes away, this goes away. We are left with 1 upon 24, and this goes away, this goes away. So what we are left with is 6 into 2 upon 24 minus 2 upon 24. This is coming out to be equal to 0. I made some error while substituting the values. 1 by 4 into minus 1. Let me check. So it's right here. 1 plus 3, 1 upon 4, 1 upon 4 minus 1 upon 2, 4 into 2, 8 plus t cube upon cube. So this is t cube upon 3 plus half into 1 upon t square upon 2. So this becomes 1 upon 4. This is 1 plus 2, 3, 3. So t cube plus half t square upon 4. T cube by 3, t square upon 4, 1 upon 24, 1 upon 2 the cube, 1 upon 8 into 3, 24, 1 upon 4, t cube, 1 upon 2 cube, 1 upon 2 square, 8, no 4, 1 into 16, yes, 16, minus half, this gives me minus 1 by 24, this gives me negative 1 upon 32, 1 upon 42, yes, 1 upon 8 into 324, minus half, so this gives me positive negative 1 upon 32, minus 1 upon 24. What was my mean? Was my mean 0? Or it was half? So my arithmetic mean was half. This should come out to be equal to half. Median. I guess I have made some error. I need to check it. What error I made here? T square plus 1 upon 4 should t square plus 1 upon 4 t square plus 1 upon 4 plus t, so this becomes t r plus 2 r plus 3 upon r plus 3, 1 upon 4 r plus 1 upon r plus 1, and t r plus 1 r plus 2 upon r plus 2, half to minus half. 6 is outside. Where did I commit a mistake? This is t cube plus 1 upon 4 t cube upon 3 let me check if my rth moment is correct from the book. Yes, I need to check my answer if my rth moment is correct. So for finding the rth moment, they have taken r as odd number and then an even number. So they are getting two different moments. So if I put in r is equal to 1, why am I getting the wrong answer here? See, I'll check my calculation and then, you know, I'll be checking my calculation again and then I'll, you know, upload this in the next video. I'll be correcting myself in the next video where I committed a mistake. I'm not able to find my calculation as well, so I need to, you know, use my pen. Here, this gives me, I need to find the mean deviation. Let's just find the mean deviation first. You see, I'll be checking my calculation and then I'll upload this in the next video. Mean deviation. So for mean deviation, I need to find the mod of x minus mu. Mu was half fx dx and my limits were 0 to 1. So x minus half. So x minus half, the mod of x minus half is equal to x minus negative of x minus half when x is less than half and greater than 0, and x minus half positive x minus half when x lies between half and 1. Right, so this gives me mean deviation as 0 to half. I'll be, you know, separating this out, minus x minus half, and 6 goes here, x minus x square dx, and plus 6 into, let me just write this on the next page, wait, let me just go to the next page. So mean deviation will be, mean deviation is equal to 6 into x minus half, negative of x minus half into x minus x square dx, 0 to half, plus 0 to plus half to 1, half to 1, x minus half into x minus x square dx. So this gives me mean deviation as my x and x minus x square plus x cube minus half x plus half x. So this is minus x and x minus x square, minus x and this minus x square gives me plus x cube. Now plus half into x, half x, so and plus half into minus x square gives me minus half x square, plus minus negative, and here I have half to 1 x square minus x cube minus half x plus half x square dx, and another bracket here, right? So this gives me the mean deviation as minus x cube by 3 plus x to the power 4 by 4 plus half x square by 2 minus half x cube by 3 is 0 to half, and plus x cube by 3 plus x cube by 3 minus x 4 by 4 minus half x square by 2 plus half x cube by 3, and this is from half to 1, another bracket here. I'm sorry for the handwriting, I need to improve my writing. 1 minus 1 by 24, I hope this calculation is correct. Four, so 2 to the power 4 16, 16 into 4 64 plus 64 plus half, this is half and half, 4 into 1 upon 4 minus half, minus 6, minus 1 upon 6 into 1 upon 8 and 0 and 0 plus this gives me 1 upon 3 minus 1 upon 4 minus 1 upon 4 plus 1 upon 6 now substituting half here. I need to, I'm just writing this expression on the next page. I'm writing this expression on the next page. So I just wrote, and I'm just writing this as next page. Wait. PTO, please turn over. Right. So for this expression, or shall I evaluate this expression first? Or wait, let me just, So this becomes, first let me just write that expression. This is plus, plus the second expression, 1 upon 3 minus 1 upon 4 minus 1 upon 4 minus again minus 1 upon 4 plus 1 upon 6 plus 1 upon 6 and now substituting half here gives me 1 upon 24 minus 1 upon 64 1 upon 24 minus 1 upon 64 1 upon 24 minus 1 upon 64 minus 1 upon 4 into 4 16 minus 1 upon 4 into 4 16 minus 1 upon 16 plus 1 upon 6 and 8 1 upon 48 plus 1 upon 48 plus 1 upon 48 6 into this expression this expression was minus 1 upon 24 and this is 16 and this is 48 so so this is minus 1 upon 48 and 24 so 24 into 48 so this becomes minus 3 upon 48 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 plus 1 upon 64 plus 1 upon 16 right 3 upon 48 is just 3 on the 3 16 3 into 16 is 48 yes so minus 1 upon 16 plus 1 upon 64 plus 1 upon 16 this gets cancelled plus now minus 1 upon 2 this is 1 upon 3 and 1 upon 6 so if I just write this as 6 to 2 3 by 6 1 upon 2 so this is 1 upon 2 minus 1 upon 2 is there plus yes it's plus here so this gets cancelled half and half this gives me 0 minus so this is again 1 upon 24 1 upon 48 this is 3 upon 48 minus 1 upon 64 minus 1 upon 16 so this becomes 1 upon 16 3 16 so what I have is 1 upon 64 6 into 1 upon 64 plus this is 0 minus into minus 1 upon 16 minus 1 upon 64 minus 1 upon 16 I was scared for a bit that I've again solved it incorrectly 16 and 16 goes away so what I'm left with is 6 into 1 upon 64 plus minus minus plus 1 upon 64. This gives me 6 into 2 upon 64. 2 and 64 goes away, 32. 2 3s are 6, 2 16s are, so this gives me 3 upon 16. So my mean deviation is 3 upon 16. My mean deviation is 3 upon 16. Let me check if what I've done is correct. Yes, my mean deviation is 3 upon 60. Now I need to find beta 1 and beta 2. Formula for beta 1 was mu, the third moment is respect to the mean, the whole square of that, and 2 I guess, and beta 2 was mu 4 upon mu 1. I need to check the formula. Here is my beta 1 and beta 2 to check for the formula. Beta 1 and beta 2. Yes, so my beta 1 is mu 3 square, mu 2 square, mu 2 cube, and beta 2 is mu 4 and 2 whole square. It's very big. For the rth moment about the mean, I'll be uploading the solution to that in the next video, because what they had done is they had taken r as 2n plus 1 and 2n, so you would have two different moments about the two different rth moments about the mean, and then they had solved that, and I also made some calculation. I would have to check that. I'll be uploading that in the next video, so please keep up with me. For beta 1 and beta 2, this is I need to find this very lengthy mu 3 and mu, the formula for mu, the third moment with respect to the mean. The formula for this is the third moment with respect to the origin minus 3 times the second moment with respect to the origin to the first moment with respect to the origin plus 2 times the first moment with respect to the origin, the whole cube of that. So mu 3 minus 3 times mu 2 mu 1 plus 2 mu dash 1 whole cube, right? So mu 3 mu dash 3 is ex cube. This is x cube fx, so 6 x minus x square dx 0 to 1, which is 6 x to the power 4 x to the power 5 upon 5 minus x to the power 5, so this gives me x to the power 6 upon 6, 0 to 1, which is 1 upon 5 minus 1 upon 6, 30, 6 minus 5 1 upon 30, this gives me 1 upon 5. Not that lengthy. So and I already have the value of mu dash 1 is equal to half, that is the mean. I need to find mu 2. Let me insert some slides. This is a very long video, I guess. So let me just check. Oh, this is 1 minute 9 tools. Let me just change this a bit. output timer is 2 hours 35 minutes. So I was just changing my output timer so that my recording doesn't stop. So far we have recorded for 1 hour 10 minutes. Now I need to find pens, ink, felt pen, yes, the color, yes. So I need to find this, which is ex square, which is x square fx dx. So my limits will be 0 to 1, 6 comes out, this is x minus x square dx. So this becomes 6 into 0 to 1 x cube minus x to the power 4, x cube minus x to the power 4 dx, which is 0 to 1, which is, stop the recording. So this is 6 x to the power 4 upon 4. Someone was knocking my door. 5, 0 to 1, 6 into 1 upon 4 minus 1 upon 5. 6 to 20, 5 minus 4, 1. So this gives me, hope I didn't make any error. So this is x cube minus x4, yes. This is 2 3s are 2 10s are, so this is 3 upon 10. So I can find my third moment with respect to the mean, which is 1 by 5 minus 3 times half into, so this is 1 by 5, which is the third moment with respect to the origin, minus 3 times the second moment with respect to the origin, that is 3 by 10, into my first moment with respect to the origin, which is half, plus 2 times my first moment, plus 2 times my first moment, the whole cube of my first moment, which is 2 whole cube. So this turns out to be 1 by 5 minus 9 by 20 plus 2 upon 8, 1 upon 4, which is 1 upon 5 minus 9 upon 20 plus 1 upon 4, which is, now 5 and 4, 24 plus 9, this becomes 9 upon 20 minus 9 upon 20, which is 0. Therefore the value of my beta 1 comes out to be equal to 0, because this is equal to the third moment, the whole square of the third moment with respect to the mean, and the second moment with respect to the mean, square of and cube of that, and this is equal to this was equal to 3 by 10, so the whole cube, and this was 0, which gives me 0. And when beta 1 is equal to 0, we can imply that the distribution is symmetrical, right? So we had to prove this. Now I need to find the fourth moment. For finding now what is beta 2, for the fourth moment I need the formula for the fourth moment is m4 dash minus 4 times, these formulas are too big, so either you can remember them, by practicing again and again, or they'll wish that they're given to you in the exam. Just 3 times. It is 3 times. The first moment is with respect to the mean, with respect to the origin. Is this formula correct? 4 m4 dash minus 4 mu 3 dash mu 1 dash plus 6 mu 2 dash mu 1 dash whole square minus 3 mu 1 dash to the power 4. And this is ex4, which is 6 comes out, 0 to 1, x to the power 4, x minus x square dx, which is 6, x to the power 5, x to the power 6 upon 6, and this becomes 4 6 x 7 minus x to the power 7 upon 7, 0 to 1, which gives me the value as 6 into 1 by 6 minus 1 by 7, 42, 1 by 42, this is 1 by 7, right? So now I already have the value of this mu 3 dash 1 and this and this, and I have all of the values. Now I can just substitute. So my value of the fourth moment with respect to the origin was 1 by 7. I just found this out. I need to substitute this in the expression. This gives me 1 by, the expression was 1 by 7. The formula is 1 by 7 minus 4 times the third moment with respect to the origin, which was 1 by 5, and then the formula is half. See, I'm just seeing the formula from the previous slide, I'm just not opening it here. The half is this, half is this 2, so this is the square of half into 5 by 10 into 3 by 10 into 3 by 10, the square of half into 3 by 10 minus 3 into half to the power 4. What was 1 by 5 here? What was 1 by 5 here? 1 by 5 was yes, this was 1 by 5, right? This is my formula. I have write this correctly, yes. So upon finding this, I get 1 by 7 minus 4 by 10 plus 6, 1 by 4 into 3, 18, 18 by 4 into 40 minus 3 by 16. So this becomes 1 by 7 minus 4, 10, 40 or 16 into 32, 16 into 3, 48, 16 into 80. Can I, 4 into 8, 32 minus, so this becomes minus 4 into 8, 32 plus 18 into 2, 36 minus 3 into 5, 15 minus 15 upon 80. This gives me 1 upon 7, 32 and 36, 4 minus 15, so minus 4 minus 15 plus 4 gives me minus 9 upon 80, and 7 and 80, what can be the LCM? 7 and 80, 80 into 2, 160, 80 into 3, 560 into 80, 80 into 7, 560, so this is 80 minus 9 into 7, so 9 into 7 was 63, so 63, so mu 4 is 80 minus 60, 20, 20 minus 3, 20 minus 3, 17, 17 upon 560, and we know that 17 into 2, 34, 17 into 3, 30 plus 51, so no, 80 minus 60, 20, 20 minus 3, 17, so this is my value, right? So let me just go. So now I need to find the value of beta 2. Beta 2 was m4 upon m1 m2 square, 2 square. So now so we had found m2 dash, which was equal to 3 by 10, and m2 was 3 by 10 minus 1 by 2 whole square. This is the variance, so this becomes, the formula for this is m2 is equal to m2 dash minus m1 dash whole square, which is the variance. This is the variance, so this is ex square minus ex whole square. So this becomes 3 by 10 minus 1 by 4, 10 and 4, 20. I can take 20, so this becomes 3 into 6 minus 1 by 4 into 5, 1 upon 20. So beta 2 becomes 17 upon 560 into, now the square of this becomes 1 upon, this is 400, 220, 2 2s are 4 and 8, 2 10, 2 10s are 20 and 2 14s are 28, 2 5s are 10, 2 7s are 14. So this becomes 50 and 35, 85 upon 7, 50 plus, yes, 85 upon 7. So is my beta 2 equal to 85 upon 7? I don't know. I think I've made some error. I always think that I've made some error. Let me see. I might have. Excuse me if I have. Let me check my value. 85 upon 7. This is coming out to be 15 upon 7. 7 should come here. 15 upon 7. This should be 15 upon 7. I've made some error, I guess. Wait. So this was 4 upon 10. 4 upon 10. 5 into 10 plus 18 upon 40 minus 3 upon. I didn't this correct. 4 into 8. 32 minus 32 plus 36. This becomes 4. Positive 4. 15 minus 4 becomes 9. 4 9 plus 4. Wait, fuck, I'm so sorry, I'm so sorry. I've lost the ability, I guess, to do basic calculations. So this is not 9. I'm so sorry. This is actually, so 15, so this becomes minus 11, right? So this is, so this was 560, so 80, and this was 7, so 77. So is this 3? So this is 3 upon 560. So I just need to write 3 here. I need to erase this also. So I was left with 5 after, cancelling everything out, and I had 3 here. So 3 into 5 becomes 15, and my final answer becomes 15 by 7, which is correct. And 15 by 7 is when I find out this becomes 2 point. They have written it like this: 15 upon 7 is equal to 2 point something something. I'll be writing the exact value, 2.14, right? So my beta 2, I found out the beta 2, I found out beta 1, I found out, let me just check what I needed to find, what all I needed to find. Yes, so I found this AM, we found AM, GM, HM, mean, median mode, rth moment about mean. Yes, I need to upload this. I found this beta 1, beta 2. I showed you guys that the distribution is symmetrical. Why? Beta 1 turned out to be equal to 0. Mean deviation was 3 upon 16, something like that. So we found all of the values. I'm so sorry for the slight calculation errors that I make here and there. And also I'll be uploading the rth moment about mean again in the next video. The same question only I'll be uploading again. So I'm so very grateful for you guys to bear with me. If you like the video, if you guys like the video, just share it with someone whom you feel might need this, right? And drop in a comment if you think I've made some other error, or if you just like the video. Thank you, and I hope to see you in the next video.